Planes are made of the metal called aluminium. Aluminium. Yeah, if you made planes out of the same metal, iron, and steel, because that's iron with a tiny amount of carbon in it. If you made steel cars and steel aeroplanes, they'd be much, much heavier, and flying an aeroplane would cost 10 times the amount, because you've got to have a heavy aeroplane using lots and lots of fuel to get into the air. Aluminium's definitely the best one to use. Aluminium is found in the rocks called bauxite. You could use lithium and magnesium. Actually, mag alloys with aluminium and magnesium are used, but lithium, the same metal, is much, much lighter than aluminium. It's used for laptops and phones, and unfortunately it's a bit reactive, and you'd have lots of airplanes like catching fire and stuff. Not so good. Bauxite has lots of aluminium oxide, Al2O3. Al2O3, yes. To extract aluminum in America, that second I is not in the American spelling. For aeroplanes, the Al2O3 is heated to 950 degrees C to melt it to a liquid. Then electricity is pushed in by a cathode. Then the electricity is pulled out by an anode. Electricity through liquids is called electrolysis. Okay, so at the cathode, what happens is aluminium from the bauxite rocks has 3 electrons given to it in the cathode to begin aluminium. That's the stuff you need for aeroplanes. And also for your laptops. Your laptop lid is made out of aluminium. At the anode, the electrons are taken away, given at the cathode, taken away at the anode. At the anode, the half equation, the oxygen in the bauxite, Al2O3, remember, the oxygen has electrons taken off it, so it becomes oxygen gas. Electrical power forces electrons into aluminium at the cathode. Electrical power takes electrons from oxygen at the anode, making oxygen gas. Let's check, make sure that does work. 3 electrons are given to each aluminium cation to make airplanes. 2 electrons are forced on each oxygen anion to make oxygen gas. Combine the cathode and anode equations. And the oxygen gas then reacts with the graphite of the anode to make CO2, which is less dangerous. So that oxygen gas would not be a good idea to have it hanging around in your factory. Combine the cathode and the anode equations. The half equations to make a whole one. Okay, 4 of this lot plus 6 of this lot means 12 electrons are given and 12 electrons are taken away. Multiply the brackets. So that's 4Al3 plus cation plus 12 electrons plus 6 O2 minus 12 electrons goes to Al. Oh, how many oxygens are we making? 3. Whoopsie. Simplify. Well, that simplifies with that. So now we only have 12 O2 minus Cool. Let's have a dash dash there. It tells my students that it needs a 1 and a 2. Much better. 4Al liquid plus 3 O2 gas. We know it is 4 times the cathode reaction plus 6 times the anode reaction because the electrons cancel. Full stop. 2AlO3 becomes 4Al plus 3 O2 gases, making 6 oxygens in total. This is the overall equation. Full stop. Half of the reaction happens at the liquid aluminium cathode. And the other half at the solid carbon anode. Oops. The carbon reacts with oxygen to make carbon dioxide. Yeah, so oxygen gas, don't say that there, because that's not what you finally get. Electrolysis needs the Al2O3 to be molten, so it is heated to 950 degrees C. The melting temperature would be even higher without sodium aluminium fluoride called cryolite. Yes, when you add something, it decreases the melting point. Aluminium collects at the cathode to be made into aeroplanes, and the oxygen collected at the anode and reacted. Cool! Did you spot the one mistake I made on purpose? Send me a message if you spotted who's going to be first. Circle my picture to get more of my videos. Press like, press subscribe. Bye!